Let's look at some examples of how to find the horizontal asymptote. Again, remember that you're always comparing the degrees, right? So the degrees are the important part. So if we look at this polynomial on the top, we've got 4x squared minus 3x plus 5. So the squared is the highest power, so we're comparing the squared on this one. If we look at the bottom, we've got 2x squared minus 7, so we're going to compare the squared on the bottom. So these powers match, okay? If you don't want to remember the three rules, then you can think about the reasoning. So really we're looking at 4x squared over 2x squared, and we don't really care about the plus the other stuff because it becomes negligible as we put in really, really large numbers or really, really, really small numbers. So these cancel out, so we get 4 over 2 or y equals 2. The shortcut, or if you remember, is that when the degrees match, you take the leading coefficients. So this becomes our horizontal asymptote. Oops, that's not how I wanted to write that. Remember, your horizontal asymptotes are always y equals the number. Okay? If we look at this next one, again, we're going to compare the powers. So we have 3, 1, none. So 3 is our highest power. So our degree is 3 on the top. On the bottom, we have x minus 1, so our degree on the bottom is the unsaid 1, right? So that means that the top is higher. If the top is higher, that means that there's no horizontal, but there is a slant. We haven't talked about how to get the slant yet, but there is a slant, okay? Now, depending on which book you're using, some will say there's only a slant if it's 1 degree higher. Technically, there's still a slant, even though this one is 2 degrees higher. The slant asymptote just happens to be parabolic in nature. Okay? But we'll talk about slant asymptotes a little bit more later. But the idea is that if the top is higher, then it's not going to have a horizontal asymptote, but it will have a slant. Okay? Sometimes the slant asymptote is also called an oblique asymptote. Okay? So slant or oblique are the same thing. Okay? If we look at this next example, we've got the 2x minus 3 on top. So the 1 is the unsaid 1 is the power or the degree on the top. On the bottom, we have x squared minus 5x plus 6. So our quantity squared is the degree on the bottom. So this means that the bottom is lower. The bottom's lower, remember, you're really doing 2x over x squared, so it's a relatively small number over a really large number. So small over large really goes to 0. So, or you can just remember if the bottom is bigger, then it goes to 0. So our horizontal asymptote is y equals 0. If we look at this example, we've got x squared minus 4 over x squared minus 6x plus 9. So these are squareds and they match. Right? So when they match, you use the leading coefficients out in front. So in this case, we have a leading coefficient of 1 and a leading coefficient of 1. So we get y equals 1 over 1, which is just 1. And that is our horizontal asymptote. Notice on all of my horizontal asymptotes that we have y equals, right? That's important. If you don't put the y equals, you're not quite correct, and you will get docked points if you don't have the y equals. So make sure that you have the y equals part.